All right, hello algebra students. Our lesson today is on 3.5, graphing linear equations in slope-intercept form. So a couple of important things you need to know. First of all, slope is the rate of change. This is going to be known as rise over run. Rise, notice in these notes down here, rise is the change in y, and run is the change in x. So there's actually a formula that we can use to find slope. That formula is right here. Slope is also known as m. You may have seen this in our linear equation model, y equals mx plus b. So the number that multiplies by x is the slope. That's the constant for linear functions. In example 1, we are going to describe the slope of each line and then determine its slope. To describe the slope, we're going to describe it as positive, negative, 0, or undefined. So notice these pictures in the concept summary up here. If a line is pointing upwards to the right, so it rises from left to right, it's a positive slope. If the line falls from left to right, so moving left to right, it's going down, that's a negative slope. If it doesn't go up, it doesn't go down, it's just flat horizontal, that's a slope of 0. And then if it's straight up and down, it's undefined. One way I like to remember this is slope dude. If you imagine a little person walking on the line, they're moving uphill, left to right. The person always has to be walking left to right. So uphill on a positive slope, our little person is going downhill on a negative slope, down, negative. On a slope of 0, they're not going to go anywhere. They're just going to walk straight, not going up or down. That's 0. And then if we have a slope dude here, it just doesn't work. The slope dude falls, he runs into a wall, he can't go anywhere. That's undefined. It's not going to work, it's undefined. All right, so let's start by describing our slope. We just looked at slope dude. We know if it's moving down left to right, it's negative. So example A has a negative slope. Example B moves up left to right, so has a positive slope. And same with example C. It's going to be positive, it moves up left to right. All right, now remember slope is the change in y over the change in x, rise over run. So when we're looking at example A, we're looking at this point to this point. If we look at the y values, it starts at 3 and then it moves to 1. Y moves down 2. Change in y is negative 2. And then we look at the change in x. X starts at negative 4. 5 and moves right 5. So x moves up 5. And our slope is going to be negative 2/5. All right, so let's look at example B. Our y value starts at negative 1, and then it moves up 1, 2, 3, 4. It moves up 4. And our x value starts at negative 3 and moves over 6. So our slope is going to be positive 4, 6. And of course we can simplify this to 2/3. All right, even though the last one is at whole number intervals, it's a little tricky because if you notice the axis counts by 2, so the points look as though they're in the middle of a point. So we're just going to use the formula for this one. It's good practice to use the formula anyway. Remember in the first slide we said m equals y2 minus y1 over x2 minus x1. So change in y over change in x. Doesn't matter if the 2 or 1 goes first as long as the 2's line up over each other and the 1's line up over each other. That means you're using the points from the same pair directly above each other. All right, so let's plug in our numbers. We're going to use this first point. This is our x1, y1. And then the second point, this is going to be our x2, y2. So my y2, look at the top, is 4. So m equals 4. y1 is negative 3, so 4 minus negative 3. Over x2 is 5. Minus x1 is 2. All right, let's solve this. 4 minus negative 3 is the same thing as 4 plus 3, which is 7. And 5 minus 2 is 3. So our slope is 7/3. And we can check that with our graph. It looks like it went up 7 and then over 2. Example 2 says the points represented by each table lie on a line. Determine the slope of each line. What that's saying is that these points in the table are all ordered pairs. So x is 4 and 1y is 20. That's an ordered pair. All right, and to determine the slope, we are going to use the slope formula again. So I'm going to write that at the top. Remember, that's m equals change in y over change in x, or y2 minus y1 over x2 minus x1. All right, so all we got to do now is plug in points. I'm going to use this first one as x1, y1, and then I'll just use the second one as x2, y2. So y2 is 14, y1 is 20. I'm going to say 14 minus 20 over 7 minus 4. 14 minus 20 is negative 6. 7 minus 4 is 3. Negative 6/3 is the same thing as negative 2. So in example A, m equals negative 2. All right, and then in B, I'm going to use this first one as x1, y1, and the second one as x2, y2. So our y2s, our y2 and y1, we're going to plug in as 2 minus 2. And then the x's, we have 1 minus negative 1. This is going to be 0. Because the y value doesn't change, this would look like a horizontal line on a graph, which remember, slope of 0. So example B has a slope of 0. The y value does not change. Before we solve example 3, we're going to look at this core concept at the bottom. Slope-intercept form is written in y equals mx plus b. This is the most common form you're going to see linear equations in because it's easy to find that y-intercept. That y-intercept is the b value, and then m is the slope. We've been finding slope. So when example 3 asks us to solve each equation for y, remember when we rewrote literal equations in lesson 1.5, kind of bringing back a little bit of that. To solve each equation for y, we're just going to have y on one side by itself, which means that our equation will be in slope-intercept form. So in example A, I have negative 2x plus y equals negative 3. To get y by itself, I need to move that negative 2x because it's negative. I add 2x to both sides to get rid of it. And then we're going to be left with y equals positive 2x minus 3. All right, and then in example B, I have a positive 6x over here, so to get rid of it, I'm going to subtract 6x. And now I have negative y, be careful not to drop that negative, equals negative 6x plus 8. Now, why did I write the 2x in example A and the negative 6x in example B first? Because mx plus b, the intercept is second. Just the way I'm doing it, in example A, you might have written y equals negative 3 plus 2x. All you have to do is flip those around to get the final answer. All right, so negative 6x plus 8. Obviously, I cannot have a negative y here, so I'm going to have to multiply this whole equation by negative 1. And then I have y equals positive 6x minus 8. That's going to be our final answer. Example 4 is just going to give us some more practice determining the slope and y-intercept. Remember, y equals mx plus b, our slope-intercept form. This is the slope, and this is the y-intercept. So in example A, where's the slope? Where the m is, m equals 3, slope is 3, and the y-intercept is negative 4. That's all you have to do for example 4. But what happens when there is no x, like in B? That means that m was 0, because anything times 0 is 0, and then it cancels out, so that's what got rid of the x, m was 0. And the y-intercept b is 6.5. And now C, you actually have to rearrange before finding m and b, which I think would be good practice. So if you want to pause the video now, solve that yourself, and then check to see if you got it right, that would be a good idea. All right, I'm going to go ahead and solve it. So I want to get y by itself. First thing I got to do is get rid of that 5x. I'm going to add 5x to both sides. Now I have negative y equals 5x minus 2, and I cannot have a negative y, so I'm going to multiply this whole thing by negative 1, and now I have y equals negative 5x plus 2, which means m is negative 5 and b is 2. All right, moving a step forward, we are going to graph each linear equation. So we know that m is the number by x, so in this case m is 4, and we know this number is the y-intercept, which is b, so b is -4. To graph this, I'm going to assume each point on the axis goes up by 1 and down by 1. To graph this, I'm going to start by putting a dot at b equals -4, since that's my y-intercept. And then I know my slope is also 4, so each point from that is going to go up 4 over 1. So I counted that up 1, 2, 3, 4 over 1. Next point is going to go up 1, 2, 3, 4 over 1. And that is the line for y equals 4x minus 4. All right, let's do example B. This one I have to rearrange quick, so we're just going to move the 2x, subtract 2x from both sides, and now I have y equals -2x plus 2. All right, so 2 is my y-intercept, so I'm going to do a point at 0, 2 on the y-axis. And then my slope is -2, which means each point from that is going to go down 2 over 1. Down 2 over 1. I'm just going to keep counting points so then I can make my line. And that is the graph for y equals -2x plus 2. All right, some summary questions for you. What is slope and how do you measure the slope of a line? Slope is m in the equation y equals mx plus b. It is rise over run. How do you measure it? It's the change in y over the change in x. When would a line slope be equal to 0? That's when you have a horizontal line that doesn't go up or down. When would a line have an undefined slope? That's when you have an up and down line that just doesn't work. And how can you use your knowledge of slope, y-intercept to graph an equation without using an input and output table? Just like we did in the last example, you start at the y-intercept, so plot that point first, and then with slope, you can just determine where the next point is by the rise over the run.